Today we're going to be talking about this question: why do we need the same fair shares? So yesterday we talked about what a fair share is. It's when we have a fraction or a shape that's broken up into equal parts. All the parts are the same size and shape. So in these two examples, we have fair shares. All of these parts are the same size and shape as all of these parts. That makes it easy for us to add this 1 to these 2 and end up with an answer of 3/4. But check out what happens when we try to add two fractions that aren't split up into fair shares. This one's split up into halves, and this one's split up into thirds. When we try to combine them, we kind of aren't sure what our answer is. We can combine the parts and get an approximate answer, but we can't give an exact answer. So what we need to do is we need to convert our fractions into the same fair shares. Well, we can see that 1/2 here is the same as 3/6. If I take the same shape and break it into 6 parts, then 3 of them out of those 6 are the same thing as 1 out of 2. And I do the same thing with 1/3. Take the same shape, break it up into 6 parts, and I see that 1/3, 1 out of 3, is the same thing as 2 out of 6. Let's go back to the original problem. Only now I've converted 1/2 into 3 out of 6. They're the same thing. I've also converted 1/3 into 2/6. It's the same thing as well. Now when I try and combine these two numbers, I can actually give an exact answer. We don't have to give an approximation because we were adding the same fair shares, and so 3/6 plus 2/6 equals 5/6. Now for adding numbers like 1/2 and 1/3 together, it's pretty easy to just use a fraction bar to come up with equivalent fractions. But for most fractions that we'll add together, we're going to need to use a different method other than fraction bars to find equivalent fair shares. So for example, I could have the problem 1/3 plus 1/4. Now this broken up into thirds and this broken up into fourths, they're not the same fair shares. But rather than try and find equivalent fraction bars, I'm going to use a different strategy. I'm going to take both bottom numbers, the denominator, and make a chart with them. All right, so there's my denominators on the top. And what I'm going to do now is I'm going to list their multiples. So the first multiple will always be that number times 1. So 3 times 1 is 3. 4 times 1 is 4. Then I'm going to list the second multiple, which is just going to be that number times 2. 3 times 2 is 6. 4 times 2 is 8. Then I'm going to multiply by 3. 3 times 3 is 9. 4 times 3 is 12. And what I'm going to do is I'm going to keep going listing their multiples until I find a number that they have in common. So next up I do 3 times 4, which is 12, and 4 times 4, which is 16. Now I can stop here because I see I have a number in common. This number that they have in common is called the least common denominator. I'll refer to it in class as the LCD. So what I'm going to do with the LCD is I'm going to change both of the fractions, the original fractions, 1/3 and 1/4, into fractions that are over 12 or that have a denominator of 12. Now I have to make sure that these new fractions are equivalent to the original fractions. Here's how I do that. I need to list what did I multiply 3 times to get to 12. Well, to figure that out, I can go back to my chart. And I had to do 3 times 4 to get to 12. So I'm going to say times 4. Now here's an important rule for creating equivalent fractions. Whatever I do to the bottom number, I also have to do to the top number. This also works vice versa. Whatever I do to the top number, I also have to do to the bottom number. So in this case, I'm multiplying the bottom number times 4. So I need to multiply the top number times 4. 1 times 4 gives me 4. So we're saying that 4/12 is the same thing as 1/3. Now let's finish 1/4. I need to figure out what did I multiply 4 by to get 12. So I'm going to go back to my list and I see that 4 times 3 gets me 12. So I'm multiplying 4 times 3. And again, whatever I do to the bottom, I also have to do to the top. I multiplied the bottom by 3, I have to multiply the top by 3. And 1 times 3 is 3. Now I'm going to take these equivalent fractions and rewrite the original problem. So remember, the original problem was 1/3 plus 1/4. We changed 1/3 and 1/4 into 4/12 and 3/12. So we rewrite the problem as 4/12 plus 3/12. Now when I'm adding fractions that have the same denominator, all I have to do is add across the top and keep the denominator the same. So if my denominator is going to stay the same, then I already know that 12 is the denominator in my answer. Now I just have to add across the top, 4 plus 3, and I get 7.